Hello all and welcome to this project on PAN card tampering detection. In this project, we will discuss tampering of PAN cards using computer vision. This project will help different organizations where their employees provide them with IDs for verification, and the organization can know whether the ID provided by their employees is original or not. As you know that with advent of technology, there are certain cases where users provided fake IDs or fake Aadhaar cards, PAN cards, etc. So this is a way how you can check whether the ID provided to you is original or not. Currently, what the companies do, they check it with the online system. Like if you give them the Aadhaar number, they'll check it online and get back to you. But with this project, you can do it instantly. You just have to upload the image and you can check whether the original image is matching with the PAN card provided or not. So let's see how we will do this. We'll do this project in 10 simple steps, in which first we take the images from the user. We'll find the threshold, we'll find the size and the format of that image. We'll change the shape and size of the image that we get from the user to the original PAN card image. Then we'll convert that image to grayscale to find the similarity index. After similarity index, we'll find the threshold of the image, contours, and grab those contours using IMUtils. Next, we will create a bounding rectangle using those contours. After that, we'll plot difference, threshold, original, and tampered image, which we will compare and get to the score of similarity to decide whether the image is tempered or not. So let's get started. For this project, we will be using Google Colab, as Google Colab provides high computational power and CV requires that. You can change the computational power of Google Colab to GPU and TPU using the notebook settings in the edit section. You can go to notebook settings and select your hardware accelerator as required. For this project, we won't be requiring any GPU or TPU hardware requirements, so we'll continue with the normal RAM and the disk allocated to us. So let's start. So the purpose of this project is to determine the tampering of PAN card using computer vision. And as I have already told you, this project will help different organizations into detecting whether the ID, that is the PAN card provided to them by their employees, is original or not. We will calculate the structural similarities between the original PAN card and the PAN card uploaded by the user. Initially, we need to import all the necessary packages. So let me tell you about them one by one. So from skimage.metrics, we will import structural similarity, which will help us in finding the structural similarity score between the original image and the tampered image or any other image which is user provided. The IMUtils library, it helps in grabbing the contours of the images, which we'll see later in this code. We'll import CV2, that is computer vision, for all the image processing requirements. From PIL, we will import image, which is required for downloading the image and visualizing the image. We'll import request, which is used to fetch the data from the URLs, as we are going to take images from different URLs. So we'll use request for that. So let's run the cell and import all these libraries. So as our libraries have been imported, let us now create two directories where we will store our images. So we'll create a directory named PAN card tampering, in which we will create a folder named image to save our images. This mkdir command is make directory, which will make a directory named PAN card tampering, and inside that we'll create a folder named image. So let's run this cell and see what it does. So after running this cell, we can check our directories here in the file section. We'll see that a PAN card tampering name folder is created. Inside that, an image folder is also created. So let's move forward. So now let us get our images from the internet. I have used two URLs, one for the original image and one for the tampered image. I'm saving both these images in different variables as original and tampered. You can take any variable name you want. For original image, I am using image.open, which is image is a function of PIL. It opens the image and gets it from the request URL. This URL request is fetched by request function and saved into the original image. Similarly for tampered one. Let's run this cell and download our images. It's done. So now let us check the format of the images and the size of the images. For this, we'll use the dot format function and the dot size function. It will tell us about the format of both the images, the original one and the tampered one, as well as the size of both the images. Let's run this cell and know what is the format and the size of both the original and the tampered images. So here we can see that the original image format is JPG while the tampered image is in PNG format. Similarly, the original image size is 1200 by 800 and the tampered image size, it's about 282 by 179. Now we'll resize both the images into same size. As we can see above, the size of the images differ. So now we'll save both these images into same format and same size. This function will resize the images into 250 by 160. Also, you can see here that I am saving the original file, which is in the JPG format, into the PNG format here. This will save our JPG format into PNG format and in the PAN card tempering folder. So let's run this cell and save our images into the directory we have created with the same size. As we can see here, the size of both the images is reduced to 250 by 160 and now both are in PNG format. We can check the images here also. Here we have original image and the tampered one. Similarly, we can change the required type from PNG to JPG. We just need to save it as the format we want. We have already used it as a PNG, so we can skip this step. But if you need to change this to a different format, you can do by running this cell and changing the formats. Now let us visualize the original and the tampered images that we have. So for that, we'll simply run original and see the original image. So this is the original image of the PAN card we are using. We'll use this image to compare the tampered one with this. Now let us see the tampered one. So this is the tampered image or the user provided image. The image that the user will provide to the organization, his ID, PAN card in this case. We'll compare this tampered one with the original one and find the similarities or dissimilarities between both the images to know whether the image is tampered or not. Now let us load these images using CV2 and apply some of the CV2 functions on it. So for loading these images using CV2, we'll use the cv2.imread function and read these images from the PAN card tempering folder. In which image folder? Let's run this cell and load these images using CV2 so that we can apply CV2 functions on them. As you can see, the cells have been loaded. So now we have original and tampered image using cv2.imread function. Now we'll convert these images into grayscale format because in image processing, many of the application doesn't help us in identifying the important edges of the colored images. Also, the colored images are a bit complex to understand by machine because they have 3 channels, that is RGB, while the grayscale has only 1 channel. So we'll use CV2 functions to convert this image from color to grayscale. So as you can see here, we have changed the variable name as original gray and we used cv2.cvtcolor original and converted to cv2.color gray. This will convert the images into grayscale. Both the images we have convert original as well as tampered. Now let's run the cell and convert our images. So we have converted our images into grayscale. Now the most important step is to find the structural similarity between both the images. Structural similarity means structure of the image is compared to the structure of the other image and difference between them is noted as a similarity index score. So now let us find out the structural similarity index between the two images. For this we have used structural similarity which we have imported above, and we have passed both the images, the original gray image and the tampered gray image. Now let's run this. For the difference, we are dividing it by 255 to normalize it and printing the SSIM score. Now let's run this cell and find out the similarity score. So as you can see here that the similarity score is 0.31, which is 31%. So the structural similarity index, it helps us to determine exactly where in terms of XY coordinates, the location, the image differences are. Here we have tried to find out the similarities between the original and the tampered image. But as we can see here that the SSIM score is pretty low. So we can say that the images are not much similar to each other. They are around 31% similar to each other. But that's not the only thing that we need to compare, or we need to make a decision on that whether the image is tampered or not. So let's see what else we can do. So let's find out the threshold and the contours of the images. In CV2, all these functions are predefined. You don't need to worry about them. So we'll start with CV2.threshold and find out the threshold of the image. Similarly, we'll find out the contours of the image using the find contours function. And these contours are then grabbed by the imutils function. The imutils grab contours. Here you can see that CV2.threshold, we pass the difference that we calculated above. Image size is 0 to 255, and we convert this into threshold binary, and similarly threshold OTSU. We'll save these value into the thresh variable and the contours value into CNTS variable. Now let's run this cell and save these values. So the threshold function, it applies an adaptive threshold to the image, which is stored in the form of array. This function, it transforms the grayscale image into a binary image using a mathematical formula in the backend. Similarly, for finding the contours, we need to use the function find contours, and it works on the binary image to retrieve the contours of the images. These contours are really useful tool for shape analysis and recognition. We'll use imutils to grab these contours and apply them later on. So the next step will be creating a bounding rectangle of the image. So creating a bounding rectangle, we need to use the contours. So we are looping over the contours we have stored in CNTS, and we are creating a CV2.rectangle over the image using this function. So in this loop, as you can see, we are trying this loop for C in contours, and we are using X, Y, width and height. That is the CV2.bounding rectangle. A rectangle has X length, Y, width and height. And for finding this, we are using the CV2.rectangle function, passing the original image. This will create the bounding rectangle for the original image, while this one will create the bounding rectangle for the tampered image. So the bounding rectangle, it helps us in finding the ratio of the width to height of the bounding rectangle of the object. We compute the bounding box of the contour and then draw the bounding box on both input images to represent where two images are different or not. Now let's run this cell and create our bounding boxes. As you can see, the code has run. So we have created the bounding rectangle. Now we just need to visualize the images using different functions. So first we'll display the original image with the contour we have created. So as you can see here, this is the original image with the contours. You can see here that this income tax department is a different contour. Similarly, different functions we can see here, different bounding boxes we can see here for each and every element on the PAN card. This is the original one. Now let us see the contour version of the tampered image and how it looks in terms of similarities. So here we can see that it is not much different from this one, but yeah, it has some differences in it. So we can say that contours didn't help us in deciding whether the images are similar or not, as we can see here that there are not much differences between both the images. Now let's visualize the difference between the images with black. And for that we'll use the from array difference image. Let's plot this. So here you can see that it will show only the difference. If there is no difference between the original image and the tampered image, we won't be seeing these black portions. These black portions only display the difference between both the images. As we have already calculated the difference above, that difference is used here in the different images, and the difference is shown in the black one. This black portion, as you can see here in the image, all the black portion, it is the difference between the original image and the tampered one. Similarly, we'll find the threshold with white. Let's visualize that. So here we can see that the threshold difference between the original and the tampered one is really high, as the white portion, here you can see this white portion, it shows the threshold difference between the original and the tampered one. And you can see that it has a much difference because a white portion has acquired most of the space in this image. So we can say that the images are not similar, they are different from each other up to a certain extent. So from both these images, this difference image and this threshold image and the SSIM score, we can conclude that the image the user provided us, that we have stored in the tampered variable, it is actually a tampered image. And you see how easily we have calculated the SSIM index and came to this conclusion. So the summary of this project is we find out the structural similarity of the images, which helped us in finding the difference or the similarity in the shape of these images. Similarly, we find out the threshold and the contours based on those threshold for the images. We converted them into grayscale binary. Also helped us in shape analysis and recognition. As we have seen that our SSIM score is around 31.2%, we can say that the image user provided is fake or tampered. Finally, in the end, we visualize the differences between the images using the displaying image with contours, difference and threshold. The scope of this project is, this project can be used in different organizations where customers or users need to provide any kind of ID in order to get themselves verified. The organizations can use this project to find out whether the ID is original or fake. Similarly, this can be used for any type of ID like Aadhaar, voter ID, etc. You just need to replace the original file with the original ID, that is, if you want to do it for Aadhaar, or if you want to do it for voter ID, or if you want to do it for any other ID or any other document, you just need to upload the original document in the original one and the other one that you need to compare in the different variable name, and so follow the same format as we have done in this project. Do it for Aadhaar, or if you want to do it for voter ID, or if you want to do it for any other ID or any other document, you just need to upload the original document in the original one and the other one that you need to compare in the different variable name, and so follow the same format as we have done in this project. Now let's see how we can create a Flask app of our model. Here I have created a project folder named PAN card tempering. In this I have created several files which are required for a Flask app. Let's see one by one what are their uses and how to create them. So this is a config file. Here we are importing the required libraries, that is, we are importing OS, and from OS we are importing the environment. We have created a class named config in which we have set debug and testing as false. In the base directory variable, we are storing the path of the file. Similarly, I have taken a secret key, PyAnalytics. You can set it to anything that you want. And in the uploads, we will upload the app path. We'll set session cookie secure and default theme as true and none respectively. Similarly, we'll create two more classes, one for development config and one for debug config. In the development config, we will set debug equal to true and session cookie secure equal to false. And similarly, in debug config, we will set debug equal to false. And we need to save this file as config.py. The extension should be a Python file. This file will be saved in the folder named PAN card tempering main. Now let's move to another file, which is the main file for this app. In app.py, we see that we have imported app from app, and this will run our app. As we can see here, it shows app.run, so it will run our app. Now let's see the init.py file. So in init.py file, we are importing Flask from Flask, setting the app variable as Flask and the name, and we have called the configuration from our config.py file, and we are importing the views from here. So as we are importing the views here, let's see what's there in the views.py file. So in the views.py file, we are creating the model that we have already created in our Google Colab. So here we see that we have imported some required libraries. From app, we are importing the app, which will help us in run this application. From Flask, we are importing the request and render templates. Flask is the front end is used to make the front end of this app. We are importing OS. We are importing structural similarity from skimage.metrics. Similarly, IAMutils, CV2 and image, as I have already explained you in the project on the Google Colab. Here I am adding paths to config files, and we are calling the app.config initial file upload and set the path here. Similarly for the existing file and for the generated files also. This code here @files also. This code here @app.root and methods equal to get and post, it will return to the home page. Now we'll define a function named index. So initially, as we run the app, it will set it to get and it will show the index.html file. And as soon as we upload the file here, the file for classification, it will run the post command. And the post command, I have run all the same commands that we have run in the Google Colab. Like, we will resize and save the uploaded image. We will resize and save the original image. We'll read uploaded images as array and do a grayscale, and then we find out the structural similarities. We will also calculate the threshold and contours, as I have already told you in Jupyter Notebook. We'll save these contours into CNTS variable using IAMutils, and then we will use these contours to make a bounding rectangle using cv2.rectangle function. We have already completed this in the Google Colab. We have already seen what all this do. Now let's see if we need to save all these outputs. So we'll use CV and we save these generated files into a path that is set for the generated file variable. Here we'll return the render template, which is index.html, and we will return the prediction here. This is the main function which will allow our app to run. So this completes our views.py file. Now let's see the index file. So this index file is an HTML file which is used to design the front end of our app. You need to have a basic knowledge of HTML and CSS to design this. Here you can see that I have set the title of our project. I have linked the reference to materialize.css. We are using the materialize.css. So you need to get familiar with materialize.css, and also you should know how HTML works. All these functions are related to HTML, setting the body of the app, setting the navigations, creating divisions, containers. You can go through this and you can design it on your own also. So this is how I have designed this app on my end. You can change this and set it according to your design. Now let's see what are some of the other files that we will be using to create this app. Here in the static folder, we can see the CSS, the generated folder we have created, the JS file, the JavaScript, the original files, and the uploaded ones. Other than that, the most important files to run this app or to deploy this app are the proc file. So in this proc file, we can see that it will tell that This is a web app, and this unicorn app:app will run the app.py file, and we have set the timeout as 60 seconds for response. Similarly, this requirements file is also very important. It will tell what are all the requirements for this app, for this project. We can do this manually by typing all the requirements that we have along with their versions. Other than that, you can go to command prompt, go to the folder where this is stored, like, let me show you. If you go to the Anaconda command prompt and you go to the folder where you have this project, you can run this command pip reqs, and it will create the requirements file in that particular folder, which will contain all the requirements for that project. As you can see here, I have already created it, so it successfully saved my requirement file in the same folder with the requirements.txt. Other than that, I have created a readme file, which are the steps to run this application. So first we need to create the copy of the project. We will open the command prompt and change our current path to the folder where we can find our app.py file. As I have shown you, app.py file, we need to set the path for that. Step 3 will be to create an environment by the command given below. We can create environment. You can change this environment name according to you. You need to activate this environment. After that, you need a command to install the required dependencies. As I have shown you, you can use this for creating requirements.txt file. After that, we simply go to the command prompt and run this using python app.py, and you will get a URL. That URL you need to copy it to the browser and run it. You have a sample data folder here, as you can see. So in order to deploy our app, we need to first upload all the code on GitHub. You can go to github.com, as you can see here. Create an account. After creating an account, you will see this page. We'll go to new repository. We'll create a new repository for this project, and it will be named as pan card tempering. You can choose any name that you want. You can set this to public or private as per you, and we will create this repository. As soon as we create the repositories, we'll upload all the existing files that we have. So let me drag and drop all the files required for this project. So this is my main folder, which contains all the project files. I'll drag this and I'll drop this here. So here you can see that all my files are getting uploaded. All the required files, I have dragged them and dropped them here, and they are being uploaded right now. It contains all the files that we had: app.py, config.py, proc file, which is the most important, and the requirements.txt, one of the important files. So as soon as the files get uploaded here, we will commit the changes. So it will save our files into this pan card tempering repository. Till our files get processed, let's take a look at Heroku. So you need to go to this link dashboards.heroku.com, and here we will create a new app. So we'll create a new app by clicking on create new app. For that, you first need to create an account. I have already created my account. You need to create an account and go to dashboard.heroku.com. Click on create new app. We can choose any name that we want. For this, we'll use pan card tempering. Currently, it has only 2 regions. So we'll select United States and we'll create an app. Let's check if our files have been uploaded or not. So here you can see that all our files have been uploaded here into the GitHub account. So this is the link to our repository. github.com, your username and the name of your repository. Now we will connect our Heroku account to our GitHub account. So as we created an app named PAN card tempering, we can choose different methods to deploy. Here I am telling you how to deploy it using GitHub. So we'll connect GitHub to Heroku. We'll click on this. We'll search for a repo. So PAN card tempering. We'll connect this. So now our GitHub account is connected. And we have taken the repository for PAN card tempering here. We need to choose a branch to deploy. Here, all of our project is saved in the main branch, as you can see here. So we'll select the main branch here and we will deploy this branch. So as soon as we click on the deploy this branch, it will start downloading the dependencies for this project. As you can see here, it already detected it as a Python app and it's installing all the required dependencies, like it will install the Python, it will install pip, all the setup tools and all the required libraries that we have passed in the requirements file. That is why the requirement files is the most important file. Similarly, for this to understand that this is a Python file, proc file is also very important. So currently it is installing all the collected packages. It has installed all the packages and now it is compressing our project and converting it into an app. So we'll see that after compressing, it will provide us with a URL and that URL will be the URL for our app. The total size of our app is 149.7 MB and this is the URL for our app. It is released. Now let's copy this URL and check if it is working. So as you can see here, this is the front end of our app which I have designed. You can make any type of front end using different HTML and CSS styles. Let's check if it's working or not. So we'll browse and select a file for this. You can take the tampered one. Let's check it. So it's showing us that it is 28.57% correct, which means it is tampered. So this is how we can create a computer vision app. We created all the required files as I have told you, the proc file, the requirements.txt, app.py, configuration file, and all the necessary files that were required. After that, we uploaded our project on GitHub. We created an account on Heroku and linked our Heroku account with our GitHub account. Then we create an app using Heroku and connected our repository for which we want to create an app, and the Heroku deployed our app on the internet with this link, as you can see here. Here you can see that this is the front end of our app. Go ahead, you can try different front ends, you can try different methods to upload the files by applying different techniques. Thank you.